In this lesson, we are going to learn about using the stoichiometry flowchart. One of the beautiful things about this stoichiometry flowchart is that it allows us to use the unit on the flowchart as well as the conversion factor on the flowchart to convert from one unit in chemistry to another unit in chemistry, just basically by following the direction on the flowchart. Now, what do I mean by that? But before we do that, let's look at the part of the flowchart. If we look at the flowchart as a whole, there are boxes, right? And each of the boxes represent a specific unit in chemistry. So the box represents units, and each box represents a specific unit, except for representative particles. And representative particle is a categories of unit that represent molecules, atoms, ions, formula units, and particles. So all of those units right there are part of the representative particles unit as a whole. And then here we have mass, and the unit of mass must be in grams, of course. Then we have mole. Then we have volume. Notice how a specific box represents a specific unit. In addition to having a specific unit in gram for mass, it has a term mass. So if you are given anything that's not in gram, you can convert that mass into gram. Or down here, if we have volume, that's not given to us in liter, but it gives us a unit of volume, we can convert to liter. Once we have liter, we can now use the stoichiometry flowchart. So be careful with that. Sometimes they don't give us in gram or they don't give us in liter. They give us something else. For instance, I can give you milligram for mass, or right here I can give you milliliter for volume. But we all know how to convert those units into liter or grams. So again, the box represents a unit. Then we have the arrows, but if you notice the arrows go in two ways. Why is that? Remember, conversion factor is an equivalent ratio of two different units. That says we can go one direction of the arrow to go to a different unit, or we can go to the other direction of the arrow to go to a different unit. It depends on what is your given and what is your unknown. So now let's go back to our problem and to see if we can figure this out together. Here I have the systematic format of applying conversion factors, so keep that in mind and we're going to use that. So we always start with our given and we multiply the conversion factor until we get to the unit of the unknown, which is we are solving for in the first place. So let's do an example problem. Here I have a beaker containing 47.5 grams of carbon. Notice carbon is the identity of a substance. How many moles of carbon are in the beaker? So this is our given right here. Our given is 47.5 grams, and we can abbreviate that into G, and carbon is represented by the letter C. What about our unknown? Our unknown is question mark, how many moles of carbon? So we can say, hey, it is question mark moles of carbon. So that is your unknown right there. Now we just plug this into our systematic application. First of all, our unknown is question mark moles of carbon. So we're looking for the unit mole of carbon. And then our given is 47.5 grams of carbon. And again, we always start from our given. And what is the unit in this case? The unit is gram. So we're going to go look for gram. But wait a minute, we have side A and side B. And the answer is always start on side A. And this is where side A is gram. So that is where we start. Okay, this is where we start. Now where do we end? We are going to end at the unknown. Notice how I start at the given and end at the unknown. So what is the unit of our unknown? Notice how the chemical is still carbon and carbon. So therefore we're not going to go to side B because B and A represent different chemical. In this case, the chemicals stay the same, so we stay on side A. So where is mole? We have mole B and mole A. Oh, there you go, mole A. So there you go, we just have to go down here. Then we are done. So this is where we end right there at the box of mole A. How do we apply that to our systematic approach? Again, we always start with our given, which is 47.5 grams of carbon. Then we follow the arrow on the conversion factor. Notice how we start and we end here. So we go in this direction. We have to multiply by that conversion factor. Look at that. You don't have to guess anymore or using this as a puzzle, but the flowchart tells you exactly which conversion factor to use first. So we take that and we multiply, right? So we take a given, time that conversion factor. In this case, let's look at it. We have 1 moles of A equal to number of grams of A. If this is a unit gram, so the gram is going to be on the bottom because the gram needs to cancel out. So the unit gram of carbon on the bottom. If grams on the bottom, the other part must be on top, which is 1 moles of A. Now, what is A in this case? We know A is your carbon because the chemical carbon in the problem. So look at that. Gram cancel out with gram, carbon cancel out with carbon. What does that give us? That gives us 47.5 times 1 mole of carbon divided by the number. In later videos, we are going to talk about finding this number, but for now, let's focus on learning how to use a flowchart. And that would be our answer. And if we were to write this on a computer, we would have 47.5 times 1, which is 47.5 moles of carbon divided by a number. And that would be the answer that you would type on your Chromebook. And that's all you have to do when we have to look for the unknown using the stoichiometry flowchart. So let's try this problem. Here we have a beaker containing 37.0 moles of copper. How many grams of copper are in the beaker? Here is our given, which is 37 moles of copper. So this is the number, this is the unit, and this is the identity of the substance. So that's our given. What are we looking for? How many grams of copper? So the unknown is pretty much question mark grams, abbreviated with the letter G, and the symbol Cu for copper. So here we have our given. Let's go back to the systematic approach. We always start from our given, but before that we need to know where to stop, which is our unknown. So we have question mark grams of copper. That's what we want to solve for. But what are we given? We are given 37.0 moles of copper. So we have 37.0 mole of copper. With our given and unknown, we know where to start and where do we end. We always start on the given and end at the unknown unit. So where is moles of copper? And again, which side do we always start? Of course, always on side A. And what does A and B represent? They represent the chemicals. So in this case, let's look for mole. Where is mole? Oh, mole's right there. So here we have moles. This is where we start. Okay, I'm going to write where we start. We start at the box, not the arrow. The arrow are the conversion factor. And where do we end? We end at grams of copper. Where's grams of copper? Oh, here it is. Grams of copper right there. Why don't we go to the B side? Because we are still talking about the same chemical. If we go into the B side, we're talking about different chemical. So therefore, we start and we go up here, and that's where we end. And how many conversion factor do we multiply by? Just that one. So let's multiply it. Here we have 1 moles of A equal to grams of A. What is gonna be on the bottom? In this case, mole is our given. So we look at the conversion factors, therefore mole is gonna be on the bottom. So we have 1 mole of A, but what is A? The identity of a substance in this case is copper. If 1 moles of A is on the bottom, the other part must be on top, which is the number of grams of, what is A in this case again? It is copper. And look at that. We have our unknown unit gram of copper at the end. So we are done. Now let's simplify it. Moles of copper cancel out. And what does that give us? We have 37.0 times the number of grams of copper. 37.0 times number gram of copper. Again, we're going to focus on finding this number later. For now, just learn how to use a flowchart. And that is being divided by 1. but we can ignore the 1. So our answer on the Chromebook will be 37.0 times the number, grams of copper. Of course, we use x to represent our multiplication sign. In this problem, we have a beaker containing 1.5 moles of calcium carbonate. How many grams of calcium carbonate are in the beaker? So again, our given is 1.5 moles of calcium carbonate, so we can write that given equal to 1.5 mole of CaCO3. And what are we looking for? How many grams of calcium carbonate are in the beaker? So our unknown is equal to question mark gram CaCO3. And with that information, we know where to start and stop on the stoichiometry flowchart. We always start from our given, which in this case, what is the unit of our given? It is moles of calcium carbonate. And which side do we always start? Of course, we always start on size A. So in this case, we're looking for mole. Oh, here you go. That is where we start, at that box. And where do we end? We always end at our unknown. So in this case, it is grams of calcium carbonate. Oh, here it is. This is where we end. So again, how many conversion factors do we have to multiply? Let's start from where we start and go up to where we end. In this case, we only use one arrow, so therefore one conversion factor. So let's plug everything in. Our unknown is question mark grams of CaCO3 or calcium carbonate, and we always start from our given, which is in this case 1.5 mole of calcium carbonate, and time the conversion factor, which is 1 moles of A equal to number of grams of A. Well, what is on the bottom? If this is mole, down here has to be mole as well. So therefore, we have 1 mole of A. But what is A? It is calcium carbonate. And then what is on top of it, which is the other part of the conversion factor? So the number of grams of calcium carbonate. We don't write the word gram, but we can use G to represent gram. And what is A? Again, is the chemical, which is CaCO3. And notice how moles of calcium carbonate cancel each other out. Give us at the very end 1.5 times number grams of CaCO3 and divided by 1, which we can ignore. So therefore, this is what we type in our Chromebook. In this problem, a beaker contains 33.0 grams of carbon. How many atoms of carbon are in the beaker? So this is our given 33 grams of carbon, and our unknown is question mark atoms of carbon. So let's plug it in to our systematic approach. We have 33.0 grams of carbon. And what is our unknown? Question mark atoms of carbon. So again, we always start from the given and end at the unknown. We always start from our given. In this case, the unit's grams, so of course, always start inside A. So this is where we start. And we end at atoms of carbon. But wait a minute, I don't see atoms anywhere. Here I have represented particles that have mole and volume and grams. And for mass A, oh, look at this closely. Atom is right there. It is part of the representative particle. So it is one of the represented particle. So this is where we end. So in this case, we start here from our given, and we go down and we go across. And notice how many conversion factors do we use now? In this case, we are using 2 conversion factors, but what is the order? Notice the flow of the arrow is going this way. So to get to this arrow, we have to use that one first. So this is your first conversion factor, and followed by your second one. So again, we follow the flow chart. So let's time by our first conversion factor. In this case, if this is grams of carbon, we look at the conversion factor, so the gram must be on the bottom as well. We have number of grams of carbon. Remember, A is a variable that represents a specific chemical. And we know the chemical identity is carbon. If gram is on the bottom, the mole has to be on top. So we have 1 mole of carbon. There you go. We are done with that conversion factor because the gram cancel out. And now we have moles of carbon left. So we can move on to the second conversion factor. See how easy it is if we use the stoichiometry flowchart. So let's look at the conversion factor. Here I have moles of carbon, and look at the conversion factor. We have 1 moles of A equal to 6.02 times 10 to the 23rd represented particle A. But we know exactly we are talking about carbon, not just represented particles. So we can say, hey, I have moles right there, so therefore the mole part must be on the bottom. In this case, it's going to be 1 mole of carbon. And what's going to be on top? We don't use the term represented particle anymore. We know exactly it is atoms, right? So therefore, we have 6.02 times 10 to the 23rd atoms, or atom of carbon. And atom is a type of represented particle. Look at that, mole of carbon cancel out, give us atom just like the unknown. So how do we plug this in our Chromebook? Let's multiply everything on top. So we take 33.0 times 1, which we can ignore. So times 6.02 times 10 to the 23rd atoms of carbon over everything on the bottom, which is, here we have a number times 1, which we don't care about it. So here you go, that is what you are going to type in the computer. And I'm going to rewrite again to make it easier. So we have 33.0 times 6.02 times 10 to the 23rd atoms of carbon divided by number. And this is what it looks like if you type on the Chromebook. So now do you see how beautiful it is when we have this stoichiometry flowchart? It is no longer a puzzle at all, but we know where to start and where to end, what conversion factor to use first, what conversion factor to use next. In this problem, I have a beaker containing 33.0 grams of sodium chloride, NaCl, which is table salt. How many formula units of sodium chloride are in the beaker? So our given is this one right here, 33.0 grams of sodium chloride. So I can substitute into our systematic approach, which is 33.0 grams of NaCl. Okay, and what is our unknown? How many formula unit of sodium chloride are in the beaker? And our unknown is going to be question mark formula unit NaCl. Again, we always start on side A. In this case, our given unit is grams, so we are going to start here. And where do we end? And then we end at our unknown unit, which is formula unit. But again, I don't see formula unit anywhere. But look at this representative particle right here. Look at that. Formula unit is a type of representative particle. So this is where we end. So let's draw our arrow. We're going from gram, and we go over here. So this is our first conversion factor, and this is our second conversion factor. So let's follow the arrow. We multiply by our first conversion factor. Notice how we have grams, so the gram part will be on the bottom. So we have number of grams NaCl. Notice how I don't write the letter A because I know my specific chemical in this case. And if the grams on the bottom, the moles must be on top. We have 1 mole of NaCl. Then we're done with that conversion factor. Notice how grams of NaCl cancel out. It was mole, which is, look at that, moles of NaCl. So now we can appreciate how beautiful that flowchart is. It's actually let us check our answer. Look at that, mole and mole. Now we move on to the next conversion factor, which is, in this case, we no longer use the term representative particle, but it is formula unit. So formula unit are like atoms. It's a specific type of representative particle. Here we have moles of NaCl. Of course, the mole part will be on the bottom, which is 1 mole of NaCl. What's going to be on the top? It's going to be the other part, which is 6.02 times 10 to the 23rd formula unit of NaCl. And look at how mole cancel out. Give us the unit of our unknown, which is over here. See how beautiful that is? So how will we type this in the computer? Of course, we multiply everything on top and ignore everything with a 1. So we have 33.0 times 6.02 times 10 to the 23rd formula unit. of NaCl, and divided by everything on the bottom, which is, here we have a generic number sign, and then we have 1, which we can ignore. If we want to write this in our Chromebook, we would write like this. We would type 33.0 times 6.02 times 10 to the 23rd formula unit / represent divide by the number. And this is what we would type in our Chromebook. In this problem, we have a beaker containing 1.3 times 10 to the 25th molecules of water. How many liters are in the beaker at STP? Now, what does that mean? Look at this number. Isn't that extremely big number? If you have that number penny, you'll be the richest man in the world, period. Okay, so in this case, we have a very large number of molecules of water. That would be our given. And we are looking for how many liters, as are unknown right there, of water at STP. So let's plug this into a systematic approach of applying the conversion factors. So we have question mark, liter of H2O. And of course you should know that L represents liter. And then our given is 1.3, and our given is 1.3 times 10 to the 25th molecules of H2O. That is the identity of our chemical. So we always start on side A and always start from a given unit. In this case, is molecule. Molecule is a type of represented particles. So we are going to start right there. But where do we end? We end at liters of water. Look at that. Liter of water is right there. So we end right there. So how does that work? Of course, we start from there and we draw it down. And this is the first conversion factor. And this would be our second conversion factor. So let's multiply it out. Notice how I have molecules of H2O. And look at that, represented particle of H2O. So let's look at this conversion factor. We have 1 moles of A equal to 6.02 times 10 to the 23rd represented particle. Notice we don't use the term represented particle, but we're going to use the term molecule, because molecule is a specific type of represented particle that we use in this problem. So therefore, what we have here is what? If this is molecules of water, therefore this part has to be on the bottom. So we have 6.02 times 10 to the 23rd going to be on the bottom. Molecules of, what is the chemical in this case? It is water. And what's on top? If the molecule part is on the bottom, the mole part must be on top. So we have 1 mole of H2O. Look how beautiful that is. The molecules of water cancel out. So we're done with that conversion factor. Look at that. We get mole right there. See how we can check our answer? And we multiply by the next conversion factor, which is this one. If this is moles of water, so therefore the mole part would be on the bottom. So we have 1 mole of A, which in this case is H2O. And the top part will be 22.4 liter of H2O. And look at that, mole cancel out, give us liter. See how we can check our answer? Or even better, how this is matching with our unknown unit. So let's simplify this. We multiply everything on top and divide everything on the bottom. So we have 1.3 times 10 to the 25th. Notice how we don't write molecules anymore because it's being canceled out. Times 1, which we can ignore, times 22.4 liter of H2O. Divide everything on the bottom, which is 6.02 times 10 to the 23rd. And that's it, we're done because this is 1. And this is our final answer. And we were to type this in our Chromebook, we have 1.3 times 10 to 23 times 22.4 liter of H2O divided by 6.02 times 10 to the 23rd. Notice this is multiplying and we have 2 numbers. To indicate that this belongs in the bottom as a whole, we have to use parentheses.